Hello everybody and welcome back to another C++ programming exercise, and in today's video we are going to be going over C++ programming exercise number 21. Now C++ programming exercise number 21 says a positive integer n is called prime if n is greater than 1 and the only factors of n are 1 and n. It is known that a positive integer n is greater than 1 is prime if n is not divisible by any prime integer where m is less than the root of n. The 1230th prime number is 10,007. Let t be an integer such that t is between 2 and 100 million, then t is prime if either t is equal to one of the first 1230 prime numbers. Write a program that declares an array of size 1230 and stores the first 1230 prime numbers to this array. The program then uses the first 1230 prime numbers to determine if a number between 2 and 100 million is prime. If a number is not prime, then output at least one of its prime factors. Okay, so now the first thing that you want to do is you want to include these two header files, cmath and iostream. Iostream should already be included, and you also want to include this constant int size. It's going to be called it's gonna have this array. It's gonna be a one-dimensional array, keep in mind, and it's gonna have a size of 1230 different elements. That's how many elements are gonna be in the array. So now we're also gonna have to declare a couple of different functions in order for this program to work. So we're going to declare a couple of functions. The first one is going to be is prime int number. And it's also going to be void after writing in that function, you can then write in void. This is going to be bool, by the way. Bool, because it's going to return if it is prime or not. Void first 1230 prime num int list comma int length. Now then we're going to write in void prime test int num comma int list comma int length. Okay, so now the first thing that you need to do is you want to come here and write in int into the main function int prime list, and you're going to name it, and it's going to have a value or a size of course, size. Of course, make sure it's the constant that you declared, not the other constant that usually pops up if you are using code blocks. And then you need to write in int number. After doing that, you want to write in first 1230 prime num prime list comma size. That is going to be what we input into the function to calculate the first 1230 prime numbers, and then we see out enter an integer between 2 and 100 million. And there we go. And then we CIN number. And then we do prime test. And then we plug in number, prime list, comma, size. And then that is the end of, also make sure that there's a C out right there. And once you put that, just put the C out right there. C out. End out. Okay, now that's the end of our main function. Just make sure everything looks alright. And from what I'm seeing, there isn't any sort of syntax errors. Now what you can do is you can just come up here, copy and paste. Right there. And there we go. Now first I'm going to go over well, actually, first we're gonna go in a sort of reverse order, in the order of most importance. Also, I just noticed that, so just fix that. So first, the most important is the prime test, of course. The one that's next of importance is the first 1,230 prime numbers, and the one that is least in importance is the is prime. So let me just highlight all of these. Okay, so now the first thing that you want to do in prime test is you want to write in int limit is equal to static cast int square root num times 1.0. So now what this line of code right here does is it just sets the limit of our program. It sets the limit of what we can actually enter inside of our program. And now something that you can choose to add is you can add a little line of code that actually prints out what is here in this variable. I'm not going to do it, but you can do it if you want to. So now you want to write in for int I is equal to 0, I is less than length, I plus plus, if num is equal to list I. We can then see out num is a prime number and then we break. Okay, so now after you write in this, you can then write in else if. Oh, and by the way, the reason that we have this in there, it's supposed to be there so that it tells you if what you are in, if the number that you inputted is a prime number. And yeah, that's how it calculates if you have a prime number. If it matches with 1 in the list, then yeah, it knows that is a prime number. So now you want to write in right here, list I is less than or equal to limit and num modulo list, which is equal to 0. And then we can enter, and we write in right here, cout num is not a prime number. And now cout one of its divisors is, and then you write in a semicolon or just a normal colon, and then you write in list I and O. And then we break from the control statement. And if that doesn't apply, then we write in else if list I is greater than limit, then we cout num is a prime number. And then we can break from the control structure, and then we'll be done with this function. So now this is a pretty self-explanatory function. I've already explained it, so I don't think it needs to be broken down any further. So without further ado, let's get to the next function, which is first 1,230 prime numbers. So now the first thing that you want to do is you want to write in list 0 is equal to 2. Count is equal to 1. Make sure all of these have list in the beginning. Int in the beginning. Int num is equal to 3. Now after all of that, you want to write in while count is less than size if is prime num list with index count plus plus is equal to num. And then num is equal to num plus 2. So yeah, that this is actually the ending of the first 1, 2, 3, 0 prime numbers function. The reason that's so short is because we're going to have to declare is prime in the next function, or is prime in its designated function. But you can see here that this is pretty simple actually. All it does is that while count is less than size, if is prime, if is prime num, if this is true, if num is prime, Then we add count plus plus, and then we up count plus plus, and we take the list with index of the new count, and it is equal to num. And then we add 2 to num. Okay, so now let's define bool is prime. Oh, and also this is repeating while count is less than size. And we also make the first number in our list equal to 2 because 2 is the only even prime number. And we set count to 1 and num to 3. And now bool is prime. So what we want to do first is we want to write in bool is prime num, which is equal to true int square root num semicolon, and int divisor, which is equal to 3, and then we write in if number is equal to 2 is prime num is equal to true, else if number modulo 2 is equal to 0, then is prime num is equal to false, else then we execute the code that's in here. Square root num is equal to static cast int square root static cast double number, and then we write a semicolon at the end to top it off, and then we write in while divisor is less than or equal to square root num, then if number modulo divisor is equal to 0, then we can write in is prime num is equal to false, and then we break, and then we write in else divisor is equal to divisor plus 2. And at the end of all of this, you want to return is prime num. So now that should be the end of the entire program. Now that we're done with the is prime function. So just going to run down through this function. And the first thing that we do is we set the divisor to 3. And now if the number is equal to 2, then the number is prime. Else if the number modulo 2 when divided by 2 is equal to 0, then is prime num is equal to false. This is pretty simple stuff, so it shouldn't be too hard to understand. Now this just applies the square root prime number law, basically. The square root of meaning that the prime number, it applies the square root law of the prime numbers. I don't remember what it was on top of my head, but what you first need to do is you need to take the square root of this number. And now, while the divisor is less than square root num, then if the number modulo divisor is equal to 0, then is prime is equal to false, and then we break from the function and then return is prime num. Else, divisor is equal to divisor plus 2. So basically now that I remember it, the square root law of the prime numbers basically means that the divisor of any number, a prime number is only prime if and only if none of its numbers that are less than or equal to the square root of itself, when divided by it, equal to 0. So basically meaning that none of the numbers that are less than the square root, as long as none of them divide wholly, then that is good. So now is prime num is equal to false. Break, and then else if we add 2 to the divisor, we do not add 1, because if we add 1, then it will be a prime number, and we always want it to be an odd number. So there we go. And then we return is prime num. So let's run this program. Okay, so else if list I less than or equal to, let's see. Let me pull up the error log and see what is wrong. So, line number 40. This is in the prime test function, by the way. So if you look at it, we see else if list I less than or equal to limit and num is equal to 0. Let me actually see what is wrong. Oh, now I see it. There's supposed to be a straight brackets right there. Let's try and run it again, and obviously it will take us to line 56. Let's see what is wrong on line 56. List I. Oh, just realized there's not supposed to be an int right there. There we go. Now it is running. So now let me enter a number. I'm gonna enter 7. 7 is a prime number. Let's run it again and enter like 4. Or so let's enter something like 64. 64 is not a prime number. One of its divisors is 2. Let's try 51. (51) is not a prime number, and one of its divisors is 3. Okay. Well, I hope you all had a good time doing the C++ programming exercise with me. And I hope you continue to have fun doing other C++ programming exercises alongside me like this. I hope you all have a great day, and I'll see you in the next video. Bye!